Okay, these are the 5-4 notes. We've been talking about inequalities, which are less than, greater than, less than or equal to, greater than or equal to. And we've been talking about how to solve them, but sometimes they're going to give you something called a compound inequality. And if you think back to the 5-2 homework where we had that tornado problem, it was on the word problems, and they said, well, we want a tornado that's in the F4 range, and so it has to be at least this big but smaller than this, where it gave us two conditions, at least this big but smaller than this. That's a compound inequality. And so you can take compound inequalities and smush them together into one inequality that has something on both sides of the variable. That might sound confusing now, but we're going to do a few examples that will make it make more sense in a little bit. So, by definition, in our textbook on page 304, a compound inequality is when two inequalities such as h is greater than or equal to 52 and h is less than or equal to 72 come together. It contains the word and. And let's say describes two conditions for an inequality. And the example that I gave you was h is greater than or equal to 72, I believe, and h is smaller than or equal to, let's go with 92. I think this is a little different than the one I read to you. So it's saying h has to be bigger than or equal to 72, but it can't be any bigger than 92. So it's just talking about a very specific amount of space. So an intersection is the graph of a compound inequality. Okay, so in order to do that, you're going to come down here, and I wrote graph, but I want you to add on to that each condition. And after we graph each condition, you can combine them into one graph that gives you your intersection. So, for example, I have x is greater than or equal to 3, and x is less than 7. So I'm going to graph the first one here, the second one here, and then I'm going to put them together. I'm going to smush them together on this last one, and we'll see our intersection. So the first one I'm going to graph, x is greater than or equal to 3. Now, before we get started, when you start doing intersections, it's easiest if you make your number lines the exact same. I know I have to have 3 and 7 on here, so I'm going to kind of estimate around the middle and go 3, 4, 5, 6, 7, so that both of them show up on my number line. Then fill in the rest. Okay, your next two should look the exact same. And the reason to do this is so that when you smush these top two together, you're not like trying to figure out, well, if this one moves this way and this one moves this way, I can smush them together. You can just say, if I were to lie these on top of each other, this is what I would get. So for x is greater than or equal to 3, I have a solid dot at 3 because it has the equal to symbol. And it's talking about the ones greater than or bigger than, so my arrow goes to the right. Okay? If I have x is less than 7 for my next one, I'm going to have an open circle at 7 because it does not have the equal to, and I'm going to go to the left because we're talking about smaller than. So now take a look at these. If I were to smush them together, do you see how I would have a line drawn through 3 because that's where it stops on this one, and I would have a line drawn through 7 because it's where it stops on the bottom one. So when I smush them together, I'm actually going to get a graph that just connects those two lines. And everything to the left and to the right of these lines is just forgotten. So when I go to graph this, I leave my dots as they are. I have a solid dot at 3, an open dot at 7, and I connect them. It kind of looks like headphones. for intersections. And I'm only worried about where they overlap. That is how you find an intersection for a compound inequality. Okay, turn the page. Now, sometimes they'll smush a compound inequality. Remember we talked about that. And instead of writing two separate ones, they just write one big one. And I was talking about this in our introduction where I said they'll write it on both sides of the variable. That's what's happening here. We have x minus 3 and then something on both the left and the right. In order to graph this, we're going to split it into two inequalities. All you do for that is you take the left-hand side, which is negative 2, less than or equal to x minus 3. You take what's in the middle and put it on the right. Then I take it again and I say x minus 3 is less than 4. So you take the middle again and write what's on the right-hand side. Now, x minus 3 is not alone, the x is not alone, so I have to do that before I can start graphing. So I solve it by adding 3 to both sides, and I get 1 is less than or equal to x. Same thing over here, I'm going to add 3 to both sides to solve, and I get x is less than 7. So now, the last thing I want to do before I start graphing is I want to flip this around. I want that x to come first. So I get x is greater than or equal to 1. It's greater than or equal to because it opens to the x over here, so it should open to the x right here. So let's start with graphing our x is greater than or equal to 1. I know I have to have numbers 1 and 7 on both number lines. And in the same place. Okay, so I'm going to put a solid circle at 1 because it's greater than or equal to, and I draw a line to the right because it is talking about greater than. Then I have x is less than 7. I'm going to put an open circle at 7 and draw my arrow to the left because it's less than. Then when I draw in my intersection, I consider the lines through each of the dots. I come down here, keep my dots the same. This one was solid. This one was open, and I draw my little headphones in. Okay, and that's how we graph an intersection. I want you to do the next one on your own. You will have to solve these inequalities first and then graph them. I want you to pause the video because I'm going to keep going. Come back to it when you're ready. Okay, so the first thing I have to do is take y minus 3 is greater than or equal to negative 11 and solve it. I'm going to add 3 to both sides. And I get y is greater than or equal to negative 8. Then I take y minus 3 is less than or equal to negative 8, add that 3, and I get y is less than or equal to negative 5. So I have only one line here, and that's okay because we kind of know what should happen when we graph these. You're going to switch them together and erase the lines. So I know I have to have numbers at negative 8 and negative 5. And I'm going to have solid dots at both of them. And it goes to the left of negative 5, but stays on the right-hand side of negative 8. So I get my headphones. Okay, turn to the next page. Now we're going to start talking about a union. And a union is a kind of compound inequality that instead of making headphones where they come together, they're going to go opposite directions and split different ways. So for union, I want you to write the definition. Another type of compound inequality that contains the word or, so contains the word or, and its graph is, okay, so it is another compound inequality and it's a union is its graph. So we had an intersection for the graph that made headphones and a union is the graph where they split apart. Okay, if you see in your word problems, if you see the word within, it means you'll have the greater than or equal to, less than or equal to symbols. And if you see the word between, it will just be less than or greater than. You'll see that in the word example after this one. So if we have x is greater than 2, I graph that first. And I know I'm going to have 2 and negative 1, so I'm going to just put those ones on there. I'm actually going to put a few on the left and right hand side. Okay, fill out the rest of yours. Okay, so x is greater than 2 gives me an open circle at 2, and it's talking about everything bigger than that. Okay, now if I do x is less than or equal to negative 1, I have a solid circle at negative 1, and it's talking about everything less than or smaller, so it goes to the left. Now when I combine these, see that they're not going to smush together and form headphones. They're going to just keep going opposite directions. So I just have to draw in both of them. You don't have to change anything. Just draw them on the same graph. Just like that. And that's a union. So intersections gave us the headphones where they connect in the middle, and unions split apart and they don't connect at all. Turn to the next page. Here is another example of unions. I want you to pause the video, do both of these on your own. Notice at the bottom one, they don't give you 3 graphs, they just give you 1, so you're going to have to remember that you have to draw them separately. Pause the video, I'm going to keep going and come back when you're ready. So I have negative 2m plus 7 less than or equal to 13. In order to graph this, I have to solve it first. So I'm going to subtract 7. I get negative 2m is less than or equal to 6. Divide both sides by negative 2. I get m. Now I divided by a negative, so my sign flips. Is greater than or equal to negative 3. Now I have 5m is plus 12 is greater than 37. To solve, I start by subtracting 12. And I get 5m is greater than 25. Divide by a positive 5. M is greater than 5. So go ahead and start graphing them. I have m greater than or equal to negative 3. So I know I'm going to have to have from negative 3 up to positive 5. So I have a closed circle at negative 3, and it's going to the right. Now I have m is greater than 5, and so I go from negative 3 to 5, and I have an open circle, and it goes to the right. Now this is something different than we've seen. Both of these go to the right, so they do overlap. Now which one do they count? We're going to come down here, draw in our number line, okay. Now this one includes everything bigger than 5. This one includes everything bigger than negative 3, which includes positive 5. So when we put these together, it's actually just this one line that keeps going, because this includes all of this. So we just put a solid circle at negative 3 that goes to the right. That's a little bit tricky, but you will see that happen on your homework. Okay, so if they overlap like this, you just take the one that's furthest away and draw that one in, because this line, if it keeps going, contains all of this line too, as well as what happens before it. Okay, so on the bottom one, we have to solve again. We have a plus 1 is less than 4. Subtract 1 from both sides, and I get a is less than 3. And then you have to take a minus 1 is greater than or equal to 3. Add the 1 to both sides, and I get a is greater than or equal to 4. So when I go to graph these, I know I'm going to have to go all the way from 3 to 4, which isn't a big deal, but I'm going to go a little to the left and right of each of them. And I'm going to say, let's go 0, 1, 2, 3, 4, 5, 6, 7. I have an open circle at 3. A is smaller than 3, so it's going to go to the left. And I have a is bigger than or equal to 4. It's a closed circle. And it's bigger, so it goes to the right. That is more like what you were seeing in that first example. Okay, turn to the next page. We have a word problem, and it reads, the human ear can only detect sounds between the frequencies 20 Hertz and 20,000 Hertz. Write and graph a compound inequality that describes the frequency of the sounds humans cannot hear. So first thing we need to notice, they can hear between these. Now go back to page, I think it's 2 of your notes. It uses the word between, so we're going to use less than and greater than for this word problem. Okay? Now, they want to know what they cannot hear. So we're not worried about 20 hertz to 20,000 hertz. We're worried about everything smaller than that and bigger than this, because that's what we can't hear. So we're going to say, let's say X is what they cannot hear. Okay? We're worried about X's that are smaller than 20, because that's the smallest that they can hear. So anything smaller than that, they can't hear it. And we'll say or. X's that are bigger than 20,000. 20,000 is as big as they can hear, so everything bigger than that, we can't hear it anymore. So now we have our compound inequality. And since it uses the word or, this is a union, which means we're probably going to have ones that split. So if I go to graph this, I'm going to need to go all the way from 20 to 20,000. I don't have 20,000 tick marks on my number line, so what I'm going to do is I'm going to say 20, and I'm going to draw these little squiggle marks in there, and that's going to represent that it's changing, but I don't have enough room to write it on there, all the way up to 20,000, okay, at this mark. And all that means is we skipped a little space. We didn't have to see it because we know that that number is really big and it doesn't fit on our page. Now, we had the word between, so we just have less than and greater than, which means open circles at both of these. Okay? We're talking about everything smaller than 20, so to the left of 20, which includes like 19, 18, 17, and everything to the right of 20,000 because it's bigger than that. And we know that that's like 20,001, 20,002, and so on. So this would be our graph of the frequencies that humans cannot hear. This is the end of the notes. If you have any questions about the differences between intersections and unions, send me an email and I'll try to help you out there. Otherwise, I want you to take a look at your homework. We'll go over some examples tomorrow in class, and you also need to finish the homework assignment from the 5-3 homework. See you tomorrow.